Okay, today we're going to look at base E and natural log. So these are logarithms that we see in nature in growth and decay problems, and they work the same as logs, but base E is the exponential form of natural log. So we'll look at first, just like we did with our logarithms, changing from exponential to logarithm to natural log, from natural log to exponential, and then we'll go into solving. So there's a lot of examples on your on your notes page, and we're just going to go through one of each type just for time's sake. So we see this in nature, E in exponential growth and decay. It's just like E is a number kind of like pi. It's 2.718, and it keeps going on and on and on, and we usually round it to 2.72, and that is a continuous rate of change. So if it's compounded continuously, then it's either growing at a continuous amount and it's exponentially and decaying. So base E, this is your base E function, and this is the natural log function. So you can see that they're just inverses of each other. So one is just the inverse of the other. So if I have E to the x equals 23, normally we had this 2 to the x equals 8. And remember, we wrote log base 2 of 8 equals 2 to put it in log form. Well, if we did this log, same thing here, base E of 23 equals x, but log base E is natural log. And we put it as ln. It's ln on your computer, so on your calculator. So it'd be natural log 23 equals x. And we don't write it as log base E because natural log's base is E. So we want to make sure we understand that. So that's putting it in logarithmic form. So this would be natural log because of the E, base E, but we don't have to write the E, of x equals 4. So that would be the natural logarithmic equation. All right, and then we're going to look at putting from natural log into E. Like I said, we're not going to go through every example just because we don't, for time's sake. So here it's like natural log base E. So we're going to put it in exponential form, same way we have. It'd be the base to the power equals x. So it'd be E to the 1.2528 equals x. And a lot of times with this growth and decay, we go up 4 decimal places when we're talking about scientific. And then also we see this in financial, and that would go up only 2. So this would be E. So you start at your base to the x equals 25. So that's how we change back and forth. Our properties on natural log in base E are the same. So our log properties continue. So here we still have multiplication is powers and addition is multiplication. So we would rewrite this as 1 log of 3 to the 4th times, because of the plus, 6. 3 to the 4th is 81 times 6, so it'd be natural log 486. So we're going to use those properties when we're looking at solving. So let's go to solving from log in exponential form, and then solving with log form. So when we're solving exponential equations and log equations that just have one natural log or one E, we're going to get this by itself first. So we have 3e to the negative 2x plus 4 equals 10. So we're working on this by itself, so including that. So subtract 4, 3e to the negative 2x equals 6, divide by 3. E to the negative 2x equals 2, And then once I have that e by itself, I change this to natural log form. So that would be natural log e, which we don't need to write, of 2 equals negative 2x. And then there's a natural log button or ln button on your calculator. Usually it's by your log button. So you're going to go natural log 2 to figure out what this is. You should get 0.6931 equals negative 2x. And then we'll just finish solving out for x. So subtract 2. Or divide by 2. Negative 2. Goodness. So x equals negative 0.3466. So that's when we have it in exponential form. We'll look at now when it's in natural log form. So we see both. So I have 2 natural log 5x equals 6. Again, same as e, I'm going to get this natural log part by itself. If it's already by itself, then you just put it into e form. So divide by 2. So natural log 5x equals 3. Then when it's by itself, put it in exponential form. So e to the third equals 5x. And the e will be like second natural log right above the natural log button. So e to the third is 20.0855, and then divide by 5. And it should tell you, I think your homework worksheet, it's 4 decimal places. But again, some of them are already here, and then you do these steps, and then some of them you have to isolate. So watch for that. All right, let's look at applying that. So we're going to look at it as an in the financial. So I'm taking out a loan or any type of savings. They're compounded continuously. So we use this e base there. And what this is known as is the PERT equation, but it actually can also be a growth equation. In science, this is financial, where P is your principal, R is your rate, and T is your time. In scientific, you see it as A e to the kt, which is the exact same equation. They just changed the variables. So I have this A equals principal e to the rt. So here I'm depositing 700, so that's what I'm starting with. So P is my starting amount. 3% interest, so my rate is 3%, or 0.03 is a decimal. And we have to put it in decimal form because these aren't in percent, so all your numbers have to be in the same form. And T, we're going to see what the balance is after 8 years. So when I put that in my equation, 700 e to the 0.03 times 8. And then that can show me, this would work the same as if I was taking out a loan for 700 and I wasn't going to pay it for 8 years. So 700, and you can just put all that in the calculator, and I get 889.87. So after 8 years not touching it, I make $189.87 in interest. Okay, we're going to do one more with this. This is a little bit different question than on your notes, so you might have to kind of adjust it. But we want to know how long it will take for me to get $1,200 in that same account, starting at 700, 3% interest rate, not knowing time. So my A on this one is 1,200. My P is 700. My T, I don't know. And my R, again, is 0.03. So when I plug that in, I have 1,200 e to the 0.03 t. So same method, or 1,200 equals, 700 e to the 0.03 t. So we're going to use that same method we did earlier in solving. So we got to get e by itself, so divide by 700. $1.714 3. Put it in natural log form because I have e by itself, so natural log 1.7143 equals 0.03t, and then divide by 0.03t, or 0.03. So I'm going to go natural log 1.7143. It gets 0.5390, and then divide by 0.03. You get 17.9697 years, so about 18 years before I'm going to have $1,200 in that account. All right, if you have any questions, make sure you come in, but thanks for watching this first.